Okay, welcome back everybody. Today's lesson is going to cover multiplying and dividing rational expressions, just like we did yesterday, except for one little difference. We're going to kind of get more into binomials. You know, they're a little bit more complicated in terms of the factoring that you have to do, and maybe it's going to be worth it to review it a little bit and go through a couple examples. Okay, let's get started. Okay, so let's look at this first one right here. It says multiply the following rational expression and simplify as much as possible. And then down here it says which values of x or y, it looks like there's x's and y's in this question, which values of x's or y will make the resulting expression undefined, which we've talked about before. Okay, so the first thing you want to do is factor as much as possible in every part of that problem as you can. So if we look at this bit by bit, all right, x plus 4, is there anything that can factor out of that? No, there is nothing. So I'm going to leave that alone. I'm going to write just x plus 4 there and leave it be. How about this one right here? We've got 3x plus 4y. Is there anything that can come out of that? Is there a way I can take an x out of that, or is there a way to take a y out of that? No. This is a little bit underwhelming here, like you thought there'd be some more stuff to do. So I'm going to leave that be. And then right here, we've got something going on. Now that is called, I know it's hard to remember all this stuff, but that's called the difference of two squares. Difference of two squares. And we know that because 9 is a perfect square and 16 is a perfect square, and difference means subtraction. Now remember, when you're finding a difference of two squares, it's going to factor into two binomials, one of which is going to be addition, the other one's going to be subtraction, or the other way around. You can write minus plus or plus minus, it doesn't matter. And then let's look at this bit by bit here. Now what is the square root of 9x squared? Well, that's going to be 3x. So I'm going to put 3x here. That's going to be your first term in each binomial right there. And then what is the square root of 16y squared? Well, that's going to be 4y. So plus 4y, and then you got minus 4y. All right, now going on to this one right here. It looks like there might be a GCF that you can perhaps take out of that, but to no avail. We cannot do that because 2 can definitely go into 20, but 2 does not divide into 3. So we can't take a GCF out of that. So we're going to have to look at this perhaps as a product sum. Now this is a little bit of a different product sum because the leading coefficient is not a 1. Now remember, when the leading coefficient is not a 1, we have to use that modified product sum method, which involves, remember this is our A, this is our B, and this is our C. And to kind of refresh your memory here, you take the A and you multiply it by the C. You take the A and you multiply it by the C, which is 40. 2 and 20, now ignore the x squared and all that, so you got 40 right there. And then what you do is you look at all the factor pairs of 40. So you got 1 and 40, you have 2 and 20, 3 does not work, but 4 does, 4 and 10, 5 and 8 work, 6 does not, 7, 8 does, but we already have that written down. And like I said, this is more of a So it's more of an alternative product sum method right here. And so you have to take the product of 2 and 20, which is 40. And then you're going to look, again, you're going to look for which of those pairs is most likely going to make a sum of 3. And the one that stands out to me, it's got to be 5 and 8. It's got to be 5 and 8. So what you do is you write the first term. And I'm sorry to start off with this, but it's maybe a good idea to start with some of these tough ones. Remember, you write the first term, which is 2x, and you're going to write that twice, right? You're going to do that twice. And then what we're going to do is we're going to put 5 here, and we're going to put 8 there. All right, now go back to this sum value right there. Now that sum value is positive 3. So how do we make 5 and 8 into positive 3? Well, in order to make 5 and 8 into positive 3, the 8 has got to be positive. The 5 must be negative right there. And then what you do is you try to simplify. Now, does 2 over 5 reduce in any way? No. But 2 over 8 certainly does. So you can turn that into 1 over 4. So this is a good one to start off with. So what you do now is you write what's left in your ratios as your binomials. So 2x minus 5 was one of the ratios. 2x minus 5 was right there. And the other ratio was 1x. I'll just write x though. X plus 4. So that was something. All right. So we definitely had some work there to do. I would probably, I don't want to promise to you, but I don't think all the factoring is going to be that crazy hard. I think it's going to be some more along the lines, especially if I give you guys Khan Academy, it's going to be along the lines of more just general product sum problems, nothing too crazy complicated. We've done all the possible factoring in every part of this problem that we could have done. And now what we're going to do is we're going to look for anything that can cancel out. Now I see an x plus 4 right here and right here. So those cancel each other out. So now it's going to be just kind of a canceling out extravaganza here. I'm going to look for as much stuff that can cancel out. So this 3x plus 4 cancels out with this 3x plus 4. And at this point in the problem, I don't see anything else that can cancel out. So what I'm left with, all that's left with on the top, is that 3x minus 4y. And that's all that's left on the bottom is 2x minus 5. We factored this out as much as humanly possible. That's what the directions say. So we did 3x minus 4y over 2x minus 5. Now that will help us answer the next question, which is which values of x or y, which values of x or y will make the resulting expression undefined. Now remember, the most important part of a rational expression is that denominator. That denominator is what makes it defined or undefined. And the numbers that you choose for that denominator will tell you. We want to set that denominator, 2x minus 5. We want to set that equal to 0. We want to see what value of x will make that denominator 0. So that's what we're going to do. We're going to solve that equation. So I'm going to add 5 first. And we get 2x equals 5. And we have one more step left. Divide both sides by 2. And there it is. So we got x equals 5 halves. Now remember, like I said before, we're not saying that x, well, I mean, I know we said x equals 5 halves. We solved it. But this is our excluding value. This is our value of x that it cannot be. This is that value of x. So if we were to put in 5 halves into that equation and then take away 5 from it, what does that give us? Well, I can work this out. Those cancel out. Those turn into 1s, and now you're left with 5 minus 5, and 5 minus 5 is 0. So that's bad. You don't want to get a 0 in the denominator, do you? So which value of x will make the resulting expression undefined? It will be 5 halves. Or I guess if you want to put 2.5, that's fine too. But 5 halves is perfectly acceptable to me, as you know. And that's it. Holy cow, that was a ton of stuff. That was a lot of factoring there. And I have to kind of apologize for it. But that was fun, right? That's fun doing all that factoring. That's good. Divide the following rational expressions and simplify as much as humanly possible. So we're going to do some factoring here. And now this one has division. Now the thing that we have to kind of keep in mind about division is that with a division, any type of division problem, you have to take this rational expression and you have to flip it. You have to flip that fraction and then you have to change division into multiplication. So why don't we just do that now? I'm going to kind of just rewrite it. Now, unlike the last problem we just did, this problem right here, just on first glance here, it appears that every part of it, every numerator, every denominator, has got some possible factoring that can be done. So let's go ahead and just get started on that. So this first one right here, if we do product sum, we're going to look at the products. We're going to look at the factor pairs of 28, which are 1 and 28, 2 and 14, 4 and 7. And remember, you're going to look for a factor pair that's going to make 3. 4 and 7 has got to be it. Okay, so we want to put 4 and 7 here in no particular order. So I'm going to put 7 and 4 here. And we want to make positive 3 out of that. So we want to make it plus 7 minus 4. 7 minus 4 makes positive 3, and 7 times negative 4 makes the product of negative 28. And then for the next one here, the one below there, that looks suspiciously like a PST, but I'm just going to do it the traditional product sum way. We got 1 and 4, 2 and 2, and you're looking for numbers that will make 4. Well, the only numbers that will make 4 when you add them or subtract them will be 2 and 2. So we're going to do x plus 2, x plus 2. So that is a PST right there. X plus 2, if you wanted to write x plus 2 squared, you could have, but I would recommend, you know what, I would be careful with that. I would recommend, especially when you're dealing with PSTs, to expand them out. Because I think sometimes people miss a little bit of factoring they could have done if they write it like that. So I would definitely write it like this. And that's what we did. All right, this next one here, we've got, we're looking at the factors of 14. So 14 is 1 and 14, 2 and 7, and I think that's it. I don't know if there's any other factors of 14. And we're looking for factors that will make 5. So it's got to be 2 and 7. It's got to be 2 and 7. So I'm going to put x here and x there. 2 and 7 here. And we need to make negative 5 out of that. So if we want to make negative 5, we want to keep the 7 negative, make that positive 2. And then we're just left with that thing right there. Now what is that called right there? That is called a difference of 2 squares, right? That's called a difference of 2 squares. So you're just going to factor a difference of 2 squares. Remember, it's just going to be a plus or minus expression. Minus plus is fine too. That's going to be x, and that's going to be x. And then the square root of 49 is 7. So x plus 7, x minus 7. Okay, you can see why I only did like a couple examples here, because these are pretty intensive. They get a little bit nutty. So we've got, I can safely and confidently assume that we've done all the possible factoring here. And if we missed anything, just let me know and I'll fix it. Again, it's a canceling extravaganza, and start anywhere as long as you're canceling stuff off the right way. So like this x plus 7 can cancel with this x plus 7. This x plus 2 can cancel with that x plus 2. This x minus 7 and this x minus 7 match up perfectly. And that is it. And what I'm left with in the numerator is x minus 4. And what we're left with in the denominator is x plus 2. Now, I didn't talk about this with the last example, but it would be okay if we canceled those x's here. No, that would not be okay. Do not cancel it that way. This x is connected to that 4 via subtraction. This x is connected to that 2 via addition. So the only thing that will cancel off that x is if there's something else exactly like it, like x minus 4 in the denominator, or an x plus 2 in the numerator. But that's it. This, I would say, in terms of what we just did, we have simplified that as much as possible. And then right here, this says which values of x, and well, there's no y here, but which values of x make the resulting expression undefined. And so you're just going to look at that x right there, and what value of x will make that equal to 0. And I know you don't need to solve this or set it up. You can do that in your head, but you got x equals negative 2. So that's the only value, you know, if you were to treat this like a function. If you were to treat that like a function, then negative 2 would be something, that would throw it all out of whack. That would not work. That would make your calculator start smoking, you know, start fizzling out on you. No, it actually wouldn't do that, but it just doesn't work. It makes it undefined. The main thing for you guys, I would say for on this lesson, is for you to just make sure you know how to factor these. And if, you know, when you're finished with them, if it looks like there's a lot more that can go out, you probably missed something. So make sure you're doing all the possible factoring, and then you know, start canceling stuff off. So that does it, everybody. That does it for today's lesson. Hopefully you guys understood this, and I'm going to sign off. All right, everyone, have a great day. See you later.